Okay, so by the way, where were we? Can't you? Okay, we did switching, right? Completed. Let us talk few things about ADM. What is ADM? Exactly. So ADM basically, this was like a what's called as a marriage between your telephone network versus data network. Okay, your telephone network versus data network, and some books even show a heart in between that to make it as a love marriage between the two. Yes, some books do show the heart in between and in a diagram, and they show that because ADM comes about the upgradation to the ADM network, but the data networks were IP based. They were not using the ADM technology. The data networks were using the IPs, and the new thing that's ADM. It took a lot of time for discussion and how to do things and how to not to do things, right? So it didn't actually replace your IP networks. The idea was to replace the IP networks or use the ADM networks, but the IP networks did stay there. But in telephone world, okay, you will see the ADM switching and all. Okay, you will see the ADM stuff in the telephone world, but not in the data world. And ADM basically was the combination of the two. It was based on the because telephone network, it was based on circuit switching, right? Your data network is about purely packet switching, okay, and your ADM was in between because what it used was the virtual circuits. Yes, is it? Okay, it was basically the ADM networks have their own protocol suite, right? So it was using the virtual circuits. In the circuit switch, we exactly connect, the physical connection is there between the wires are connected, as you know. In the packet switch there's nothing connected, we don't know anything. We have the packets, they move individually in any path whatsoever. But here in the virtual circuit, what we have a circuit which is not connected stuff, but we know actually the path that our packets gonna flow in the path, right? But they work inside internally, it works in a packets, but outside it behaves like a circuit. So that's called a virtual circuit, not a real circuit, but there is a path. Your packet's gonna follow on that. So your ATM works on that. It has fixed cells because it combines, it combines the bits. What is called here is cells. In ADM we have the cells. It combines bits to form the cells, right? But in your IP based networks, okay, we have the packets. And the difference between packets and cells is the cells are fixed, while packets, they can vary. You can make a packet of varying size, any size you want, okay. And here in the circuit switching, we do not have any stuff like that. We do not divide data like that. It's just a stream and go. In the circuit switching, we do not need, because we have a circuit made up which is bound, so no need to make it packets or frames or whatever. No, not necessary, okay. And in circuit switching we need to have a uniform, what was we having was a uniform speed, uniform data rate. What I mean to say, data rate need to be uniform. But in ADM we can have the non-uniform data rate. You have lesser data rate, you have more data rate, we can cope up with these things. Okay, so it's around 53 bytes long, wherein we have the 48, the 5 bits header and 48 bits payload in the ADM cells. They are fixed sized. Okay, but they are a bit costly, and the software was different. In IP based network, the software is different, right? So you need to convert between the two. But in telephone network, you will see the ATM is still there. Okay, but you need to get, you combine, you make the ADM cells out there, and you have to get it out. As you could see in the ADSL, we have, this is an ADSL, this is the modem, but it is also this is a combination of modem and a switch. You know what is the difference between switch and routers and bridges and hubs? You don't know, right? Yes, we will take up that thing first because that's important. Okay, let's first discuss these things, because after this splitter, as you could see here, it's a splitter. Everything is an ADM cells, but this splitter splits the things. Before I come to this, I will just talk about these things. What is the difference between the repeater and a hub and a bridge and a router and a switch, and the gateways. Okay, we have gateways also. Okay, let's understand it carefully. What is this, the difference? Because this is the basic funda. You should be knowing all these things. Now, basically, we have firstly we had the repeater or a hub. Okay, and this repeater or hub basically works in your physical layer. It works in the physical layer of the OSI model. Okay, you getting me? And the hub or receiver, I don't have a hub here, but I have one hub. As you could see here, this is the hub, this USB hub. It has some 1 2 3 4 something, 4 ports. Okay, F6, right? So what I was saying is the repeater or hub, we have here a USB hub. Okay, right? This is a hub. A hub is a non-intelligent stuff, but the repeater, repeater and a hub, little difference. Repeater will also amplify. The hub is not necessary to amplify. It can amplify, but not necessary that it will amplify. What it does is, from one port, for example, from this one port something comes, it just broadcasts it to the all ports. It just copies it to the all ports, nothing else. It knows nothing about anything. It doesn't care about what is on upfront, what is here, what is there, for which machine it was. We can't send it to for example, there's a hub, for example, as you've seen in your beginning class networks. We said the hub, star network, and like that we had a hub in between. And a hub is a stuff which is a passive. This is my hub. It has some ports, for example, and there are some computers. Okay, this is computer number 1. There are some computers which it connects, right? Okay, it's connected. It is a 4-port hub, for example, and I'm connecting 4 computers with it. Here I have this is a USB hub, and you could see a lot of stuff is with this hub, isn't it? The bumble is there, the mouse is there, the keyboard is there, a lot of stuff is there with this hub. There could be printers also, and so on. And with this hub, for example, I'm combining the computers. Okay, right? Now, what happens is this hub is nothing but a passive star. It is like a star, passive star. What comes in, for example, this guy want to send something. It can. The hub doesn't have intelligence that if you want to send this guy to this guy, it doesn't have intelligence that you have to send a broadcast packet or something, and which has the address, for example, of this machine. It will go to the broadcast means what? It will go to the all machines. What the hub does is it makes it to go in every port, and everybody is listening, right? Like I'm saying here, Azhar, right? Now everybody of you are listening the Azhar. This is the broadcast, but the address is of the Azhar, so Azhar is gonna respond. So in a hub, it is the machine who will respond whose address is in it. Okay, it's a basic broadcast. It is not intelligent. It is simply a connection stuff which is connecting the people together. You getting me? It doesn't have anything else other than that. It is just a mean to combine many computers together. But this is like a history now. The hub. We don't have the hubs now. The hubs are not coming in the market now. Okay, even the switches are going, fading away. We'll understand what is a switch. But the repeater here, when I say repeater, basically repeater is a hub. It is nothing but a hub. But repeater, in addition of the hub, does what? It amplifies. For example, you are sending something, maybe it will fade on, because when you send something, an electric signal, we have read a lot about signaling, and we know the Fourier components. It's made of always Fourier components, and there is a delay distortion, there is attenuation, and there's a lot of things. Is it or not? What is that called? Is transmission impairments. So transmission impairments do happen there. There is a noise. So your signal will fade off, right? So what happens is your repeater can get it back, will amplify it. Okay? If your signal, which is coming, okay, if it fades off, the guy on this side will amplify it back. Like you don't have an amplifier in a mosque. You speak something on a mic and you have an amplifier there. Your voice is feeble one, okay, but your amplifier will make it bigger. You getting me? It was not that big, but your amplifier is going to make it big. So amplifier means something which amplifies, and repeater does that. It amplifies. If the signal is faded, it gets it back. That is the added advantage. But the thing is there that it has a single collision domain. Means that if everybody wants to send, right, they will collide, because only one can send in the hub, if you have a hub. Because if everybody is trying to send, they will collide. That necessarily they will collide, right? So we need an arbitration here. So we'll read the how the things are done, because that we have to read from Monday. We will be reading the data link layer. We'll start doing things there, right? Getting me? There need to be some carrier sensing, that if I'm sending something, I sense the carrier, that is anybody sending or not. I make it sure that if I send it, that it has reached, to make it sure, because here there could be accidents all the way. Because if this guy is sending and simultaneously this guy is sending, they're gonna collide each other, because hub can transmit one thing at a time. This is also the disadvantage of the hub. But this was, before we had the hubs, simply a passive things to connect the computers and repeaters, and they work in data link layer. Because why we say that they work in data link layer? Because they have no knowledge of whatsoever. They just take the traffic as a bits and just copy those bits to the ports. So it's working in bits. So that means a data link layer, right? But then came the story of what is called as a switch. जी yes, one can send at a time. If two guys are sending at a time, then they will collide. Not router. Repeater, yes. Because they are passive, they have no intelligence, right? To get that intelligence, we have a switch. If you look at this, this thing is a wireless D-Link, right? 802.11g, and this is B/G. This is a backward compatible. I will tell you what is that in a short time. But this has on the back a switch also. It is a combination of a switch and a router. Okay, a switch is a bit intelligent. It has a lot of intelligence. A switch has a lot of intelligence. You getting me? So what happens in a switch is it's like this, and it works in the data link layer. That is layer number. Data link layer is how? What's the layer number? Network comes after the data link layer. Data link layer is what layer? Which layer? First or second or third? Second layer. What is the first layer? After that we have a data link layer. Then we have transport layer. Then yes, session, present and application layer. Okay. इतनी देर में आपको ये भी याद नहीं रहा? कितना टाइम हो गया नेटवर्किंग में? कोई बोल रहा है? This shows your interest. So data link layer is the second layer of the, when I said there is framing. We do framing in the data link layer, and in the network layer I said we make what? Packets. So data link layer second layer, and your switch works on a data link layer. Data link layer has actually basically the two parts. We will see that from Monday. We'll be reading that. Data link layer will take up from Monday. Okay. Now, what a switch does is, a switch is a bit intelligent. It is same like a hub. We have a lot of ports on a switch. Like you could see here, we are having the 4 ports, but this is not a switch. This is a router, but it has a switch involved. Okay, it is a router come switch. So we have 4 ports, right? So there could be a lot of ports on a switch, not necessarily 4 ports. We can have a big switch which is having a lot of ports, and basic idea is to connect them together, the machines. Again, the same way we connect the machines, right? But there, what's the difference is, whatever. So we are connecting 4 machines here. But the thing is, switch is a bit more intelligent. There are a lot of types of switches. Some switches are very advanced. They go for error checking. They have their firewalls. There's a lot of things on a switch. But a simple switch, what I will talk, a basic idea of a switch is, it's working data link layer, and what it does is, why we say it's working data link layer is a proof of that, because it stores the MAC addresses. It stores the MAC addresses. The MAC address of a machine, it stores that MAC address. Okay. So a switch learns, when you connect any computer with it, it learns that which computer is with me. What is the MAC address of that computer? Okay. And what it does is, if for example this is the machine A wants to send to the machine B, okay, it exactly sends this traffic. Okay, it will get it from this machine and get it through this machine and send it here. So that means if we are sending between these 2 machines, it doesn't have an effect if we want to send between these 2 machines. That was not in a router. In a hub. In a hub we have a single collision domain. Here the domains are different. Okay, because you can send exactly to the machine, so there is no need to broadcast. If here we have 4 computers connected. If a particular machine wants to send to the particular machine, the router exactly sends to the particular machine, so it is a bit secure. There comes a security. A hub is non-secure. Everybody is listening what's going on in the hub. But in the switch, you getting me? There's a privacy. You can set exactly because we know the machine address, and it knows that it is intelligent. It's not a passive hub. It has an intelligence. It knows exactly which machine is with which port. So any data to a particular machine will be sent to that only, not to the other guys. And that also means that you can send simultaneously the things from another machine to another machine as well. So collision domains are different. You getting what I'm saying? So it's remembering the MAC addresses. What is the MAC address? Okay, we will see that from the Monday, because we have to take up the data link layer. We will see the two layers in it and so on. But you remember one thing here, that switch is a bit intelligent and it connects the computers, remembering the MAC addresses, works in the data link layer and all. Getting me? And another difference between the hub and a switch is the hub shares the total bandwidth. Yeah. It shares the bandwidth. Hub. That means if you have more computers with the hub, they're gonna share that link. Whatever the bandwidth, total bandwidth is, that will get half to that, and some part to this, some part to this equally. But here, it doesn't. It doesn't, divide that bandwidth. Okay, that's also the difference. Then there is another device which is actually basically the less, I can say less featureless than this switch. That's called the bridge, because your switch is basically the bridge with added features, right? The bridge is simply want to connect two LANs or to whatever, just use a bridge in between. Okay, the bridge is like this. For example, you have a bridge. The simplest bridge will be that you have a computers on a hub, on a this bus. A lot of computers, they want to send, and we connect them to the bus. So rather we do this, we just put a bridge in between and just have a one LAN here and another LAN here, right? Now these are the nodes connected with the bus, but we have a bridge in between. So it will help us not to divide the band, because the whole band is divided here, right? Because they are all connected with the bus. Now they will have the bridge in between, so these are not interfered with these guys, because of the bridge in between, right? Or we can have a one LAN here. Maybe there is a two computers here, another here, two computers here, another here. As we see, the bus arbitration versus something, there is an arbiter in between. In the bus, we did the arbitration, right? We have the bus topology. Then everybody was trying to send on the bus, and we read a lot of that's the same stuff. And here with the bridge, and a switch is a bit advanced. Okay, but the question is, now we said we have a hub, we have this thing, right? Yes, what? Bridge. Bridge means we have one village on this side, another village on this side, and the Abid is here on the bridge. So that is bridge. What else? So this is bridge. If you don't have a bridge, you're gonna fall into the river, I guess. But you have what? So you have a slant, huh? Okay, good. You're not getting the bridge. The bridge is same as a switch, but switch is a bit advanced. It has a lot of ports. Okay, bridge has doesn't firstly when the bridge came in, they were portless. They were having two ports only. On one side they connect with this LAN, and this side they connect with this LAN. Then the bridges come a little bit advanced, and they become switches. And the bridge and switch, basically they the things go off. Okay. Even in this this is the ADSL modem. Okay, uh, you can connect it with the ADSL using the bridging or using as a router. You can connect this as a router or as a bridging. But if it's a bridging, you need to dial, right? But if it's a router, it knows exactly where I have to go. If you could see here, uh, this computer is on a link, I guess. Okay. Um, if it comes up, I will tell you. It's already coming, so it's not showing. Okay, if I say here like this, it's not clicking. One 92 dot. What I did? What is happening with this? Now, this is a again a this is a modem cum router again. This is in another building, right? This is a wireless router from which I connect my internet here. This is in another building, that building. And if I go for an if I want to go for a setup, okay. Now, if I want to create an setup, I will have the two things here. This is a rather new, back. Wait a second. It's not working. What's happening with this? Now this is already on a PPP or Ethernet. Okay, it's a point-to-point over Ethernet, and this is basically as a router. This is that modem, or that's an ADSL router basically. That is connected as a router, but we can connect that as a bridging. If I give a click on a bridging, then whenever I connect, I need to dial. Okay, when I need to dial to connect with to the internet. I will tell you because if you have a switch or you have a hub that is not meant to connect with the internet, because they are at the physical layer and at the data link layer. They know nothing about the IP addresses. They are unaware of the IP addresses, so they don't have capability. But this is my ADSL, as you could see here. This is ZT something, ZX DSL 83A second. This is a router as well, okay, and this is also a gateway. We will be discussing what is a gateway. This is also a gateway, okay, but we'll understand what's that. So you can you can see that I can connect a router or as a bridging. We'll come to that. First, let us learn what we are reading about. So we need to first understand what's the router. So a bridge or a switch, okay, a bridge or a switch. Forget about the hub; it is a very passive stuff. Bridge or a switch, it knows the MAC address. Your guys are connecting each other. You know the MAC address, okay, and it doesn't know about the IP addresses. That means like this. Listen, if we have okay, we have a hub. Maybe this is a hub or a switch, for example, which connecting to these are computers or whatever it is. They could be network printers or computers or whatever it is. They want to connect to each other. Okay, we have another part which is in somewhere else. Okay, this is another LAN connecting with a switch. You have put up a switch or a hub or whatever. Maybe it's a switch. I've connected my LAN to it, and this is another switch. We connected my LAN to it, and this is in, for example, Srinagar. and this is somewhere else, other part of the world. Okay, maybe it is Afghanistan. Okay, so because you can't go there to deliver yourself, because otherwise either you'll be killed by the America or you'll be taken up by the Taliban. So better you do something to send things from here to that place. But the problem is you can't use in between a switch, because when you talk about the local LANs, you need to know the machine address of that. That is your MAC address. But when you are talking about the global network, when you're talking about something which is on the internet, you want to connect with the internet, then on the internet we have given everybody an address called IP address. We'll read that in the network layer, just a 1 week down. Okay, but you understand that every machine has an IP address, and your switch knows nothing about IP address because IP comes in the network layer. And I'm telling you, switch and a bridge, they work in what layer? They work in data link layer. They know nothing about IP address. They're dumb for that. That means your switch gonna work in a local LAN, right? So if you want to connect with the internet, will you connect with the hub? I'm asking something to you guys also. Because I want to connect to the internet. Should I use the hub? Can I use a switch? Can I use a modem? Yes, I can. To connect with the internet, you need a modem. That's what this is. This is a modem. But the modem, this is a little bit advanced modem. Okay? But a modem, we need a router. But a modem is enough. We need a modem, that's enough. Why to have a router then? Because the thing is like this, because in today's world, leave about the business, I'm talking about just a home. You're in a home, okay? You have a laptop, you have a desktop as well, and you have some couple of mobile phones, right? And you want to connect everything with the internet. But your modem, right? And what happens is you have buy one, okay, IP address, or you don't buy any IP address because they are the ISPs, internet service providers. They when you connect with the internet, they give you randomly some IP address. So you have basically one IP address, but inside you have a lot of stuff. Okay, call waiting. Okay, you got it what I'm saying? What I was saying, I forgot. Yep, yeah, if you have a modem, because you need a modem, right? Because your switch knows nothing about the IP address. But I was telling about ISP. ISP is providing, it buys some, the internet service provider like our BSNL here, it buys some, because every machine, you have to understand that every machine in the universe needs to have a unique address. Everybody is a unique address. So how we do the addressing and how can we generate such a huge number of addresses? We have the IP address in classes and all that. We will see that. When we finish the data link layer, then we move on to the network layer. Then we see how is addressing done. But basically understand that few, say for example, your BSNL has taken up 100 IP addresses, and it doesn't take the only 100 customers, it takes many customers, because it knows कि all the time सारे कस्टमर एक साथ जो है ना आपके आईपी इस्तेमाल नहीं करेंगे, ठीक है? इसलिए आप जब करते हो, your address is changing. आपका एक एड्रेस आईपी एड्रेस दिया जाएगा, now you disconnect and then again connect, you will be given some different IP address. It is not static, it is dynamic. Okay, अब आपके पास IP एड्रेस है, but you wanna put some switch in between. You want to connect with the, आपके पास ये सारे जो चीज़ें हैं, लैपटॉप है, डेस्कटॉप है, lot of things हैं, you want to connect it with the switch. Switch can combine all these together, but it knows nothing about the outside world, the IP thing. It has no intelligence about that. So for that we have a router, because router works in the layer 3rd of the OSI, that is the network layer, because it does its forwarding on the basis of IP addresses. Okay. Now a modem, if you have a modem, for example, that works, we need a modem all the time. Even though we have a router, we still need a modem, which does the modulation, demodulation, right? Which basically connects it with the telephone, because the things are coming from the telephone network. And telephone network is totally different than your data network. So we have a LAN here, for example. They're all connected together, all these devices. But your telephone network is totally different network. A switch can combine between these guys internal to the LAN. It has no knowledge whatsoever how to send this packet from here to the machine which is in America. It has no knowledge about that. It can't forward that. Okay? You can broadcast in a switch, but you can't broadcast when you have a router in between. And a modem basically connects things, but a router makes it that you can connect everybody to the internet and using the same. For example, if you go see my phone, it's connected this time. Okay, using the same broadband router, right? This laptop is connected, and we have one or two laptops. My cousin brothers are there. They are connected with the laptops with the same router. As you could see here, we have the wireless router also here, the D-Link. It lets you to connect all the machines together, and it lets you to connect with the outside world, because it knows it works on a layer 3rd and works on the packets. It works on the packets, it works on the IP addresses, and it knows exactly which machine and where. And a modem cannot connect with the people. It lets you connect with the internet, which you need, right? And the thing is that today, if you look at this D-Link router, this is a router plus a switch plus a modem. This is all in one. Getting me? This is modem as well as a switch. It has a switch. You can combine on LAN. No need to connect to internet. You have 4 or 5 computers. You want to connect them together, and you can see on the back there's a 4-port LAN switch. It is right. You connect with it with RJ45 connectors. You have these cables like this cable. If you can see, right? This is the RJ45 connector, right? It just gets into it, right? You can connect it with, and if you have an internet, that is an interface to the WAN, wired network. That is here, internet. It's written here. You can see internet, right? You can connect the internet there, and it has a reset button and a power button. Reset button means the factory settings, both the factory settings, and it works as a modem router as well. It can act as a bridge as well. As I show you the software, yeah? There's the bridging, right? It is the page of the same page like this, but this is another router. This is another router, not this one. This is from the ZTE, which the BSNL is giving here, but this one is from the D-Link. Okay, and this guy can act as a bridging also. That means bridging. When I say bridging, that means it connects the LAN, but it knows, again, the bridging works on where? At the data link layer. It knows nothing about the IP. So it needs to dial. It needs what? Then you have to, every time you connect, you need to dial to the BSNL, then you get connection from the BSNL. But if you say like PPE, then what you do is you will store the password into it. You don't need to dial. Okay? It will do all the job itself. You getting me? So if you say on a PPE or SNS, next, if it, this recorder is not allowing me to click. Okay, as you can see here, now there is a username and the password and all that. It is stored inside. If you're bridging, it will not ask for that. You have to give it then you have to make a connection. You have to make a connection to connect. Then every time it will ask for username password, or in a connection you will have the username password, then you connect with it. But here you just put up if you make it a PPOE, okay, over Ethernet, right? Because this is over Ethernet, then you need not, the password is stored inside the router. Okay, username password is stored inside the router. You just open the Just switch on the router. You don't have to do anything. Just open the browser and you're able to access the internet. You getting me? The basic funda which I was telling you is about the a router. A router is a guy which will let you connect all the computers in your LAN, a personal LAN, with the internet, which have totally different IP addresses because it works in a data link layer or network layer. Network layer. Then the last thing which we have is what is called as a gateway. Now you are this guy. This one. This is the ZTE something. This is not wireless. This is simply a modem, a router, and this is also a gateway. And what is a gateway is if you have two different network technologies. Okay, and if you see on the one side we have the ISDN line, right? That this is your all ADM. This is a broadband ADM. That's what is the ADM basically? ADM is a technology, but what is this you are using? This is the broadband ISDN. Okay, so that will be from this splitter onwards. There will be all the ADM cells. You getting me? And this guy is also a gateway. A gateway is same like a router, but it allows to combine two different networks. So if we have on one side one network and other side with a different network, right? Then we need a gateway. So a gateway, they basically work in a transport layer. So we can have a transport gateway, and they also work in other layers also, upper layer, session layer also, right? Application gateway. We have application gateways. We have the transport gateways. They work in upper layer, and they allow us to combine basically because you could have a totally different network on one side. You have on one side IP based network, right? And on the other side a telephone network. That is your ISDN. How can you combine the ISDN, which is totally different network, which has the totally different structure, totally different signaling, and everything is different. And IP-based network is totally different. As I said, this ISDN is basically ADM. And ADM has a fixed cells, right? And here we have the packets, which it doesn't have a fixed cells. You getting me? And they have totally different structure, totally different modes of working. The the format of how much is the header long, how much is the body long, and the IP is a totally different thing. Your ISDN is a totally different thing. That means your router will fail there because your router doesn't know how to combine one. If it is like that, on one side you are talking Chinese, on the other side you are talking Japanese, right? So there needs some intelligence which will convert between these two different formats. So that's what a gateway is doing. A gateway knows that. It knows how to connect with this network with the other network. How to convert from this to that. You can understand very easily now. You getting me? Good. You getting me or not? Okay. So that's what comes the gateway. The gateway comes in between, which connects two different. It allows us to talk between two different networks. You getting me? So with this we finish our topic. And well, one more thing which I would like to tell you is that if you want to connect two computers without anything, without hub, without switch, without router, any such thing, if we have only two computers, but then what's called as a null modem. Just have a single wire, but this is the cross-link wire. Mind you, if you have seen the Cat5 or Cat6 Ethernet cable like this, right, which connects your modem and then your computer, that will not work. Okay, as you have seen your RS-232 standards. Okay, on one side you have a sender channel and on the other side you have a receiver channel. then you need to cross the link, because between these two RJ45 is connected, as we see here. This is a crossover link, this is a crossover cable, and this is a null modem. We can combine the two computers using this. Not that will be same, जो दूसरी यहाँ पे थी ना वो बिल्कुल ऐसी ही है, आपको फर्क नहीं लगेगा, लेकिन वो क्रॉसओवर नहीं है, इसमें क्रॉसओवर है, यानी कि इसका जो यहाँ पे ये भेज रहा था, ठीक है, जो इसका सेंडिंग लिंक है, दैट कनेक्टिविटी इसके रिसीविंग लिंक के साथ इसको क्रॉस किया हुआ है, ठीक है। यहाँ पर भी क्रॉस हो गया, क्योंकि उसमें जो होता था मेल एंड फीमेल होता था, और RS-232 स्टैंडर्ड जो हमने पढ़ा, ठीक है। लेकिन जो यहाँ पे अगर इसका सेंडर इसके सेंडर में घुसेगा, अगर हम सीधे लगाएंगे सीधी केबल, जैसे हमारी कैट 5 है, इसका सेंडर इसके सेंडर से, इसका रिसीवर इसके रिसीवर से, यानी कि वो तो कोलाइड कर जाएंगे, यानी कि इसका सेंडर इसके रिसीवर से मिलना चाहिए, ना कि इसके सेंडर से, है ना। बिकॉज इफ दिस गाय वांट टू सेंड लाइक दिस, आई विल शो इट ऑन हियर, आई एम शोइंग बाय द हैंड व्हाट्स हैपनिंग। Oh ho ho. Okay, here we go. What I am saying is, if I have I connect this is a sender and another guy is a sender, if you connect sender with the sender, they will collide because they will also send. So they need to cross over. That means this is a receiver, this was a sending link. Okay, this is a receiver and it's a sending link, right? So you need to cross. इसका सेंडर इसके रिसीवर से क्रॉस करना पड़ेगा, और इसका सेंडर इसके रिसीवर से क्रॉस करना पड़ेगा. They need to be crossed. This is called crossover cable. So this is called null modem, right? You can connect the two using the null modem, or you can connect the two with the hub and a repeater or whatever. So I guess you just give it a recap now. Yes, you got it? Yes. It needs a gateway. This is the default gateway. If you could see, if I have seen here the 192.168.11, this is 192, basically it's a private address. You will see what are the private addresses, what are the public addresses, and this is the address of the gateway. This guy is the address of the gateway. Are you getting me? This is connecting with me the same stuff like जैसे आपका ये राउटर यहाँ पे, ऐसे राउटर दूसरी बिल्डिंग में है ना, ये उसके आप नजर कर सकते हो दूसरी बिल्डिंग में, वहां से वायरलेस पकड़ के यहाँ लाता है, ठीक है। और ये उसी का पेज है, ये इट इज ओपनिंग इनसाइड ऑफ द राउटर, इस तरह का है, इसके अंदर जो उसमें है ये उसका पेज है, इट इज ओपनिंग दैट थिंग, ये सेटिंग उसकी है. और गेटिंग मी? इफ आई डू हियर लाइक if I save and reboot here, for example, if I say save and reboot, it will reboot that. That's the gateway, because gateway we need to combine between the two guys. And one more thing I would like to tell you is here is about this wireless stuff. And we say 802.3, that is the Ethernet, okay? Then 802.4, and we have token bus and token rings. Similarly, we have the IEEE 802.11. Okay, this is for the wireless. This is for wireless, right? And if you could see this, which is in my hand, okay, it is 802.11b/G. Then these B's and G's, they basically are about, you know, about what is the frequency of the radio frequency of this, what will be the you know, distance, how far it can go, what's the reach of this, okay, what is the speed of this. It is about this. And today we have the 802.11n, the newer your laptops and your, if you buy a router, okay, these days wireless routers, they will have 802.11n. Now if you have a simple work to do, like you want to just connect one or two your laptops and desktops, and you have just to surf the net and all, then the G is enough. But today the new thing is 802.11n. If you want to go for streaming videos, and you want to go for call conferencing, okay, and you want to go for streaming videos and all, right, virtual meetings and all, then you need an advanced stuff that's called 802.11n. Okay, and even today we have a dual band. We have today a dual band, which has basically two antennas, right? It has basically two antennas. 2.4 gigahertz and 5 gigahertz is the frequency. You can connect either from the 2.4 if you have the older versions, and the newer versions which are really fast, like 3G fast, you can say like that. So you have the 5 gigahertz antenna for that, and it has a more it's called dual band. It's called what? Now you will see only these guys will come up. Okay. You getting what I'm saying? So you have the dual bands today, and they have a huge bandwidth. They can connect more computers and all, right? I think that's all for today. You just give me the recap, but